So hey, Capacity Constraints Unveiled, Navigating Cloud Scaling Realities, and I am Kevin Sonney. I am a senior SRE on the capacity team at Elastic. Here are my socials, and a couple things you might want to know is that in addition to doing this, I also podcast, I raise chickens, and I go to a lot of sci-fi cons. And with me today is Marc.
Thank you, Kevin. So I'm Marc. I'm also working in the capacity team at Elastic with Kevin. And me, I don't have any social media, so if you want to find me, you'll find me at the Elastic booth after the presentation. Basically, what we do with the capacity team is we're responsible for the tooling and processes regarding providing cloud capacity for our customers, and whether internal or external. So what that means is like all the tooling required for it to make it happen, as well as making sure that we establish good relationship with the CSP so that we actually have the capacity. And also we make sure that our cloud cost control don't explode like Quinn said in the previous presentation.
Yeah. So let's just do a little brief of who is Elastic and what is Elastic Cloud. How many of you have used Elasticsearch? Wow, that's us. So that's us, right? Elastic Cloud is actually a SaaS offering of the Elastic Stack, so Elasticsearch, Kibana, Agent, all of those tools, right, deployed using our own best practices and run by the people who make it. So when you're using Elastic Cloud, you're literally getting like developer support when there's an issue or if you have questions. And we've got a brief history of Elastic Cloud. So first off, the open source version of Elasticsearch was released in 2010. So after that, a company called Found started up to offer it as a cloud service. Elastic founded itself as a company to support Elasticsearch and Kibana and the stack in 2012. And then in 2013, Docker came out. And Docker, of course, as we all know, was a big revolution on containerizing things. Elastic acquired Found in 2015 and made it into Elastic Cloud. And by that point, all of those workloads that they had started out at Found had been containerized and were being orchestrated on the back end. But there's an important note here is that Kubernetes came out in the same year that Elastic acquired Found. So all of the tooling, and this is important background information, all of the tooling and all of the orchestration that's running Elastic Cloud was invented and had to be figured out before Kubernetes. So let's talk about the dark ages. And I understand you might have already gotten this in another keynote, and great minds think alike, maybe. But in the dark times before the cloud, right, there were servers and there were data centers, and you had to do like physical constraints. There was only so much capacity you could put into a rack. You had to pay for that space, and the cloud changed that. Right? Theoretically, an endless supply of computing that someone else was taking care of, and it was easy, and it was at a reasonable price, and that's the story we were told. During that dark time, right, there was always a plan. We had to plan ahead. We had to request a budget. We had to get approvals. We had to place orders. We had to wait on delivery. We had to get them in. We had to rack them. We had to stack them. We had to wire them, right? Sometimes we'd have to wait on shipments. How many of you are from that time period, have worked in that time period? Yeah. How many of you have had to deal with the I can't get a server because there aren't parts yet? Yeah, right? And then you go through that entire process again in 3 months, in 6 months, whatever your cadence was and your projected growth, right? But Marc?
Yeah, right now, as we said, there's cloud service providers. We have 3 major cloud service providers. They're all amazing. They provide compute resources, but as well as other services that gives us tremendous capability. We have endless amount of computing power. We have endless amount of storage. You don't even need to buy disk anymore. You just put things on S3 or whatever equivalent is for your other CSP. And yeah, we also have a lot of automation regarding that. So whenever you want to provision VMs. You don't have to to buy a load balancer to go with it and all that stuff. It's just automated. You have GitOps, you have infrastructure as code, you have even ChatOps now with AI. It's really just amazing. And to spin up cloud resources, it takes seconds. And the beauty of things with our job is that we don't have to do capacity planning anymore because it's just right there. And Amazon, Microsoft, or Azure, or whatever other CSPs are just taking care of this for us. So yeah, everything's awesome, and that's it. Thank you very much for.
Yeah, if that was really the end, you wouldn't be here. I know that we wouldn't be here either, right? So let's talk about Elastic Cloud today, so that you understand what our capacity, some of our capacity challenges are. We have 64 regions across 4 cloud service providers. We have 40,000 hosts across those 64 regions, give or take. That's growing every day. 50,000 Elastic deployments. And an Elastic deployment consists of at least 3 containers each. At least 3 containers each, sometimes more. So start doing that math, right? And it's growing daily. That means that what we're managing is a poop ton of containers. Right? And for those of you who may not be from America, this does include a metric poop ton and an imperial poop ton. So let's talk about the good things that are happening here at Elastic Cloud, right? I mean, first off, I've said multiple times, it's containerized. That means that it doesn't take very long for you as a consumer to click on your cloud console and say, I need to expand the amount of memory, the amount of disk, the number of nodes for my Elastic deployment. It's really quick. You know, it's all right there in that UI. And it's orchestrated. We actually don't have to go out and do anything manual with that. When you click the button, automated processes go out, deploy containers. They do all of that automatically on the back end. It's really kind of transparent. You look at it and you can see, oh, I'm on a specific kind of machine for my high memory or my high I/O or my hot data or my warm data tiers, because we've got tiered storage, right? And so you can like do some math, and we include that math on how much it's going to cost you an hour or a month or anything like that. So it's very transparent to you as the customer. And customers love it. That's the great part. We wouldn't have 50,000 deployments if the customers didn't love it. And that's great. But there's also a bad side, right? We've had to build a lot of custom tooling to detect and update when we need capacity. Like I said, all of this happened before Kubernetes. So we don't have any of those advantages managing our backend cloud, right? Elastic containers are stateful. Anyone who's dealt with stateful loads and containers is making a noise right now, and that's fine. I made that noise too. That means that we can't quickly move things around. And once something's on a machine in a container, we have to have orchestration around that to move it. And let's be honest, the promise of cloud being inexpensive is not there. It is very expensive to run all of this infrastructure in the cloud. But with our pricing, with our transparency, it does pay for itself, which is very important. And then there's the ugly parts, right? We can't use auto-scaling as provided by the cloud service providers because it's stateful. ASGs, auto-scaling groups, are not very bright when it comes to stateful loads, and they think that something is idle because the CPU and the memory aren't being utilized, but maybe you're reading data from it. Maybe it's a storage node. Uh-oh, the ASG thinks it's not in use, so it shuts it down, and oh no, now we have to rearrange everything to recover that data. Capacity availability is actually limited in many regions. Just because it's available in US East 1, which is where, say, Amazon deploys all their new stuff, doesn't mean it's going to be available in any of the Asia Pacific regions. And because we're transparent on pricing, that means that the availability of a particular node type limits what we can deploy to in regions. Finally, our on-call team has to address when we can't get capacity. So On-Call has an entire run book on what to do when a cloud service provider can't launch a node for us.
We just said that everything was awesome and that the cloud service providers were doing everything for us, but unfortunately, that's just the rose-tinted glasses that we saw. I'll take care of this.
Okay.
Basically, like we've seen a lot of things in the wild, but remember that scale matters. What we are presenting here is what we saw while running Elastic Cloud at a scale that you can see. But if you're just like deploying a few services here and there in the cloud, and you have a startup with just a limited amount of customers, and you're spending just like a few $1,000s a month on cloud computing, you've probably never encountered any of the issues that we're going to talk about today. This matters when you're trying to run things at scale in the cloud and that you have customers that are really demanding, and that's where we are. And that also what you need as terms of compute instance, it also matters. So for example, on AWS, Gravitron is more constrained than regular Intel types of machines just because they have much better price to performance ratio depending on the workload that you're running on. It's also region dependent, as Kevin said, like US East 1 is probably fine for most instance types, but there are other regions in Europe and Asia that have just less availability and they're more constrained. So some of the error message that you've seen, we're not going to say from which cloud service providers, but
you'll be able to infer it, I'm sure, if you've seen the error message.
Exactly. But frankly, the error message does not really matter. What matters is that what the message that we want to pass on to you about is that before, when we had server racks, we developed a skill to plan for capacity. But that skill, even though it's not as prevalent in the cloud, we still have to use it in the cloud service provider, in the cloud world.
Yeah.
So how did that happen, Kevin? Why did we have so much problems with Elastic Cloud?
So yeah, how did that happen? By the way, if you notice, we're actually aiming for most memes used in a single presentation at SREcon24. So, but yeah, so learn from some of our mistakes is what I'm going to say. So I talked about that transparency in the pricing that the customers like, because we know what kind of machine our workload is running on. That means that we've tied specific instance types to specific deployment types of Elastic. So if you're running on a high CPU, that may be Graviton. Great, but then AWS runs out of Graviton, right? We can't change that sort of thing on the fly rapidly because it's so tightly tied together. Early on, before I started, like my first year at Elastic, there was still not very much planning around high demand events. Now, everybody, I'm sure, is used to the mad rush of we have to scale everything up for Black Friday and Cyber Monday in the States. But there are other events. There are sporting events in other countries where they need to scale up quickly. And if you're caught flat-footed on that, it is a problem. But we've had instances in the past, at least prior to the formation of the capacity team, where someone was literally on call all Thanksgiving weekend here in the US to scale up as customers demanded it, because we didn't have any of the tooling or any of the support we have right now. And we didn't plan for it, so we didn't already have capacity on hold, ready and waiting. So we weren't really building those relationships with the cloud service providers and doing that planning early, which also did not help. So we're going to talk later about how important communication is, but your TAM is your best friend when it comes to capacity planning, if you are of a size that you have a TAM at your provider. So sitting down and talking with them, we weren't doing it. We'd just be like, hey, why are we out of D2s in Europe? Oh, yeah, well, about that. And then not planning for the maintenance events. How many of you have had that surprise notice that one of your nodes has just disappeared because Amazon decided that that rack was old and it was time to replace? Like, yeah, it's a thing. And while they have notices in like the notice board in the thing, you have to take extra steps to like move it from whoever owns the Amazon's account email to someone who can actually do something about it and automate around it. We've also said that your TAM is your best friend because something they can help you with is to say, hey, we're not going to deploy this particular CPU type anymore because we've got a new one coming. We have not been great about that because we've pinned specific workloads to specific types of VMs in the providers. That also means that implementing new instance types is a lot of work. We have to orchestrate around, oh, well, if you're spinning up a newer, say, CPU optimized, then you need to use these machines instead of those machines. And there's tooling, and it takes extra time and planning to sit down and say, we're going to scale up. Fortunately, we are fixing that, and we're dealing with it now, and now Mark is going to talk about that, right?
Thank you, Kevin. Yes, I will. So we'll split that into two parts. First, we'll talk about how we design our new cloud offering and how we're changing Elastic Cloud a little bit to adapt for it. And second is how we can, like some of the things that we do that are independent of the product. So first, like we said that before, Elastic Cloud was tied to an instance type. And one of the things that our customers love is that we're very transparent about the instance that we run it. So you can basically do a translation about, okay, like this is my instance type on AWS, this is how it costs. So it's clearly, you're clearly able to see like what's the overhead that we take for running Elastic for you in Elastic Cloud. Our next generation of cloud offering is Elasticsearch Serverless. Basically, if you're already running on Elastic Cloud, please continue to use it. It's not a product that's being deprecated or anything like this. It's here to stay. It's just we're introducing a new offering, and some of what we want to do is just like say, hey, we've learned those things, we're getting to capacity, and that's how we are integrating in it. So with that said, Elasticsearch Serverless, we're not tying to a specific instance type. So basically, you have a set of, we have a very smart Elastic autoscaler that will change depending on the performance metrics. It's going to change the size and the number of instances that you have. And that will depend, like if the instance type that you're running on is stronger, you'll have less of it. And if it's less strong, because we're running on a lower price to performance ratio, it will, you will probably have more of it. But basically, if we look at this diagram, you can see that, I'm not going to go into the details of it, but what's important is to look at that there's a clear distinction between compute and storage. We talked before about how Elastic Cloud was stateful. We basically did a lot of work under the hood to make it stateless so that we could much more easily move things around. So that makes maintenance easier. It allows us for a lot more of flexibility. And it's really, really better for all the tooling that's involved in it. One of the things also that we made a big change of is it's now running on Kubernetes. So we talked about before about how the tooling that we had to do to provide capacity interacting with all 4 cloud service providers that we support. Now with Kubernetes, we can use the cluster autoscaler, which will natively interact with the cloud service provider. And we can also specify some instance type priorities that are defined in advance so that if our preferred type runs out, then we have a second type to fall back on. And that's really changing how we manage capacity. It's much, much easier for us. Unfortunately, it's not because we have multiple instance type priority that we don't have to plan. We still have to plan for new instance type. We still have to plan for sunsetting. It's just that we're not really as constrained about, okay, there's this specific instance type that at this very moment that is constrained for capacity, I have a backup plan. It's more a macro instead of micro. Before going into specific of what you can do with the CSP, we're going to talk about capacity reservations. Excluding bulk discounts or reservations and to save money, we're going to talk about mainly 2 types. There's a regular capacity reservations that are basically, you say, hey, at this very moment, I want to reserve X number of instances of this specific type in this specific ability zone. And once you do that, you pay the full amount of what it would cost you to run the actual VM, but you get flexibility about how you run that VM and all that stuff. It's very cost intensive because you pay for the full amount. However, you're guaranteed to have it if you need it. But we'll talk later about how you can take this to your advantage without costing more money in certain types of events. And there's also a new product that's popping out in certain CSPs. It's future capacity reservation. So basically, it's currently in preview at GCP. And what you do is that you say, hey, for in this amount of time, for X amount, so let's say in 2 weeks, I want for 1 month those number of instances. And if they get approved by the cloud service provider, then this is being translated to a capacity reservation that you will then pay the full amount. But the big advantage for it, as we talked before, is like in high demand events like Black Friday, there's more people than you that will need those instances. Everybody needs more compute power during that time. So if you can specify in advance, that's a very good tool to be guaranteed that you will get those instances. And we really hope for other CSPs to follow suit with that. Basically, one of the other things that we talked about, but we're going to say it again, is that planning and communicating is very, very important. If you need to do capacity projection to know what you are going to need. As I said before, it's really a game that you need to play if you are running at a high scale. If you have just a few services and just a few VMs, this does not really apply. But at a higher scale, you probably have a few years under your belt and you can know like, okay, in this amount of time, I'm going to need this amount. And that's really key to be able to know, okay, I'm going to need this amount in capacity reservation. And also you can use that in your advantage while talking to your TAM and say like, hey, I'm going to need this amount. I'm going to run this type of workload on this instance type. What do you think? And they may say, well, there's this new type that's coming out that's going to eventually, they're not going to say it's going to replace it, but eventually this is what's happening, right? So for example, on AWS, and by the way, we're talking about Amazon a lot. We're not like trash talking about Amazon. It's just like the biggest CSP with the most margin, but all of them have their own issue. But for example, they're introducing D3s, and they're pretty much common in all regions. And D2s are not being phased out. But if you're running new workloads, you're probably better running on D2s than D3s versus D2s. Trust us on this.
Yeah.
So basically, the planning, communicating is very important. And on capacity, first do capacity projections, then planning with the CSPs, and execute that with capacity reservations.
And also with customers, like your customers will know if they're going to have high demand.
Exactly.
Yeah. We have actually a situation right now where the cricket finals are happening. Are they actively happening, or are they over? But in India, and we have a customer who needed more capacity, but by communicating with them early, we were able to provide that.
And also, like we talked about maintenance events, and with capacity reservations, one of the things that really everyone should do is to cover at least their own fleet with capacity reservation. And what that does is that if your node gets shut down because of a maintenance event or something like this, you're guaranteed to have a replacement for it because you have a capacity reservation that covered it. And this is, you can kind of trick the capacity reservation system by adjusting it from on the fly. There's no minimum amount of time that you can reserve an instance for. So by reserving, having tools to automate capacity reservations for it, your current fleet, you're ensured to have replacement during maintenance. And when we did that, we noticed that we were much less affected by maintenance events because we saw a lot in the past that maintenance events just because sometimes a rack goes down or whatever, you get machines that get thrown off, and you try to spin up a replacement, and then whoops, out of capacity, and then you're screwed. So Kevin, can you talk to the audience about our capacity management approach?
Yeah, so now I'm going to give you some take-home actions. Some concrete take-home actions, right? So the first thing is learn to probe your capacity reservations, right? Reserve what you're using, right-size things, and then take the time to check. If you know you're going to need to scale up, use some of these tricks to like reserve extra capacity. Okay, I can get it. Let's go ahead and close that so I'm not paying for more than a couple seconds. And that way, you know you will have the capacity when it's available. Start using the future capacity reservations in the places where you have them. These things have been amazing. I cannot tell you how great it is to sit there and say, yes, I want 200 instances of this particular type in these regions on these dates. And that gives not just you the peace of mind knowing that it will be there, but it also means that the cloud provider has the time to go out and if they need to deploy new hardware, more instances, they have the time also to do it. So everybody wins because at the end of that reservation, they have more capacity to give to other customers, and you've provided what you need for your workloads and for your customers. Plan your availability zone support. Now, when I talked about the stateful situation earlier, and I talked about specific instances with specific workloads on them, that also meant it was in specific instance, or in specific availability zones. And if we say, well, we want to support people to deploy on 3 AZs, then we kind of pin things to those 3 availability zones. There are a couple places your cloud service providers have 5 availability zones or 6 availability zones. Plan to be able to spread your workload across all of those. So if a customer or you need something in 3 zones for redundancy purposes, for disaster recovery purposes, that you're utilizing all of the available zones and not just the 3 you chose architecturally at the first, when you were first deploying. That also helps with some of those constraints where they're like, well, I can get you that instance in zone E, but I'm out of it in zone A. And I'm like, but my tooling only knows about zone A, it doesn't know zone E. Right? Those are the sorts of things you can do when you have more than 3 availability zones to work with. Take your time to manage your project, project what you're doing, plan for these updates, plan for your growth, look at your historical data, and start to make projections on what you're going to need and make those reservations. That way, as you grow, you know you have that capacity. And then design for flexibility. One of the things we're doing, as Mark said, is we're starting to implement instant types priorities for workloads so that we can move things around to different instance types based on availability, based on heuristics around, okay, how many nodes of this type do I need to equal node of this type? So this is a secondary, this is our primary, but if we run out of our primary, we can fall to the secondary, to the tertiary, and so on and so forth, so that you're not tied to a specific capacity pool with a specific set of numbers. And you can actually come up with either an equivalent price performance, or maybe your performance isn't as good, but that's okay, because a service that isn't as fast is much better than not having the service at all. So be willing to take that performance trade-off in order to provide those services. If you can't get the top of the line, this is what we know for sure and have tested and gone around. And we've got about 16 minutes left, so it's time to ask questions.